This is a Panasonic RQ156S tape recorder, built circa 1965. That's when our family got it. And you see these little tapes here on the slow speed, which is set to now, would take about a half hour on a side. You could flip it over and then record or play on the other side. If you took this device here and put it over that, it would double the speed, so you could record at high speed. You get half the length, 15 minutes per side, but arguably higher audio quality. Anyway, I've got this kind of a part here. You can see in the back, this is the motor, and this is the flywheel. Everything drives off of the flywheel. And there is a belt that goes between the two that's supposed to, this motor turns and drives everything else. These belts get old and expensive. I've seen some for like $35 for this piece of rubber. They don't fit very well, don't last very long. But I had a bunch of old tapes that I had wanted to play. This one was a recording as kids we made in 1968 at Christmas when all the cousins got together, and about to go to a family reunion of sorts. They asked me if I could bring that. Well, I could bring it, but I couldn't play it because the tape recorder wasn't working. So I got creative. I decided that a direct drive had some benefits, and so I 3D printed some parts here to fit next to the flywheel. Took a little piece of latex rubber glove and double-sided sticky tape to it to give it a little bit of friction. And that sits in there, and with just a slight bit of pressure, it drives that flywheel. But to drive that, I have a stepper motor and designed this gear here that fits inside that. And being short of time, I decided that to hold this. But to drive all that, since I didn't know what speed it needed to be, I used an Arduino system, Arduino Uno, and then there's a stepper motor controller that can be driven by the Arduino, so I just breadboarded that up and rubber banded it to the back of this Arduino, and then that feeds the drive. You program this from the computer via a USB port, and that's also where you get the power from. I also have to get power 9 to 12 volts or so that goes and drives the motor. And so that's what these lines are here, is just it goes over into there to drive the motor. So motor power, Arduino power, and you download the program through that, and now it's loaded. Now I just use this connection to get the power. So I'm going to pull this off for now. Get the gears to mesh. It's a perfect fit, so getting it lined up for that perfect fit sometimes takes some doing. There we go. I've got one of the screws is off right now, but I've got a screw on either side to keep even pressure on it, and blocked off the hole so that this couldn't, if the screw slipped, it couldn't slip down and touch the flywheel, which would kind of screw things up. Here's the screw. I'll have to put that back on. Okay, I got the other screw back on. Oops. I kept these loose because it helps me adjust the angle and also facilitated printing the part on 3D without having an overhang, which is, I find to be a little bit messy. Here's the documentation. This is the actual schematic that I used. This part here is that stepper driver, and this over here is the Arduino, and so these are all the lines that connected them. Okay, really fancy documentation. So I've got this tape in here. It's kind of in the middle. I'm going to stand this up so the tape doesn't fall out, and then push this in from the side. Start the motor, and then just press it in there like that and hold it. You can hear weird sounds coming through it. That's a bunch of adolescent kids messing around with a microphone in 1968. So I'm going to start this. I can do this one-handed. With the Type A USBs, you got to get them lined up the right way. There we go. All right. So press the play, get all the gears engaged, and then press it in.
Don't try to decipher the words. I don't even know what I said. Ladies and gentlemen, due to lack of interest on the part of the news-making media, there will be no news today. Instead, there will be a program of fun and joy substituted until it is time to bring you first-hand coverage of the Ladies Auxiliary Trade Social, where there will be fun, games, and joy indeed.
And stop. So it works. The audio doesn't sound pristine, but that's probably what the original audio sounded like. Now remember, this tape is almost 60 years old, so it's almost amazing it's playing at all. And we were playing with, goofy voices and stuff like that. So let's stop this. So, haywired, but I was in a hurry, so I didn't have time to do things more neatly, but hey, it works. And so I played this back onto the microphone of my computer, and then used Audacity to convert it to an MP3 file. I can also use Audacity to change the speed. If I didn't get the speed quite right with the Arduino, which I think I actually did get it pretty much spot on, but to the extent that I didn't, or I played it at double speed or something, I could use Audacity to play with the audio and filter it and do some other things. But when I tried fixing this with the rubber bands, that didn't work very well because it made the flywheel move very irregularly because of the variable tension on it. And that's harder to correct. So anyway, there it is, my fun project for the week.